Alright everyone, welcome back to another episode of Tennis Insights. This video is on synthesis of non-essential amino acids. Let's dive right in. Synthesis of non-essential amino acids. So as I've not made a previous video on amino acids, let me just briefly discuss the structure of amino acids, what amino acids are. So amino acids, they are the monomer of protein. Amino acids are the monomer of protein. It's from amino acids that proteins are built up. Like proteins are linked up by peptide bonds to form amino acids are linked up by peptide bonds to form proteins. So let's look at the structure of amino acid. So there's a central carbon in the amino acid linked to the carboxylic acid group, linked to the amino group, linked to the hydrogen atom, and then the acyl side chain. This acyl side chain, this arrow here, can mean anything, can represent any functional group or site. It could be anything, any hydrocarbon, or it could be another hydrogen atom. It could be another hydrogen atom. This R here could be another hydrogen atom to mean glycine, or it could be a methyl group, CH3, to mean alanine, and so forth. So this right here now, this right here is the general structure of an amino acid. You see the amino group of the amino group of the amino acid. You see the carboxylic acid group of the amino acid. So let's look at because subsequently, when we're talking about synthesis, when we're talking about metabolism of amino acid, we'll be seeing mostly the ionized form of the amino acid. So this is the ionized form of the amino acid. So you can see the charges. That's what makes it ionized. The charges, the ions. So this is the ionized form of amino acid. So with that, let's get right into it. So I've said that amino acids are the monomer of proteins. There are about 200 amino acids in nature, but only about 20 are present in proteins. Only about 20 are present in proteins that are found in humans. So out of these 20, human beings can synthesize only 11. Human beings can synthesize 11, and then 9 out of the 20 cannot be synthesized by human beings. Therefore, it must be taken in the diet. And this leads us to the classification of amino acids into essential amino acids and non-essential amino acids. So yes, amino acids, they are classified into non-essential amino acids, non-essential amino acids, as well as essential amino acids. Okay, yeah, as well as essential amino acids. So let's look at the non-essential amino acid. For non-essential amino acid, how I remember it is by saying A raised to the power 4, G raised to the power 3, and then PST. So I mean, A raised to the power 4, that's A, number 2, A, number 3, A. The fourth one, it still starts with an A. Like the fourth amino acid still starts with an A. Then the fifth one, G raised to the power 3, right? G, and then and then PSTC. PSTC, yeah. So A here is for arginine, aspartate, asparagine. This A as well is for alanine. This G here is glycine, and glutamine, Proline, this is serine, this is threonine, this is cysteine. So these are the non-essential amino acids. I don't want you to be confused. When I say non-essential, I don't mean that they are not essential. I don't mean that they are not essential for health. All these amino acids, all the 20 amino acids, all of them are essential for health. All of them are biologically essential. but there are some that are not nutritionally essential. Nutritionally essential in the sense that there are some that can be synthesized by the body, hence they are nutritionally non-essential amino acids. So all these 11, they can be synthesized in the body, hence they are nutritionally non-essential amino acids. So let's look at the essential amino acids. Let's look at the essential amino acids. So how I used to remember essential amino acids by saying private Tim Hall. The private, you abbreviate it as PVT. PVT. Then Tim Hall, Tim. Then Hall, H. Then you remove the A, just write L, L. So this P now is for phenylalanine. The V here is for valine. The T here is for tyrosine. The second T here is for tryptophan. The I here is for isoleucine. The M here is for methionine. The H here is for histidine. The L, leucine, and lysine. So these are the essential amino acids, the ones that the body cannot synthesize and hence have to be absorbed into the diet. Yes. So with this now, let's go into how these non-essential amino acids, how they can be synthesized in the body, the non-essential ones. So starting with, okay. Okay, so talking about the synthesis of non-essential amino acids. The non-essential amino acids, they are synthesized from the intermediates of citric acid cycle and glycolysis. So the intermediates of citric acid cycle and glycolysis, such as 3-phosphoglycerate, the pyruvate, the alpha ketoglutarate, the oxaloacetate, these are what forms the amino acids. So let's look at, first of all, the formation of glutamate and glutamine. So glutamate and glutamine is formed from alpha ketoglutarate. So those alpha ketoglutarate is actually a 5-carbon compound. So this is how it looks like. This is how it looks like. The amino group here, and then so sorry, not this is not this actually this is not it. Yeah, this is alpha ketoglutarate. So the name of this structure is alpha ketoglutarate. Do you know why it's called alpha ketoglutarate? Do you see this here now is the functional group. The alpha group, the alpha carbon is the carbon that is bonded to the carboxylic acid functional group, the carboxylic functional group. So after the first carbon, the carboxylic carbon, the next one here is alpha carbon. This is alpha carbon, the one that is linked to the carboxylic carbon. Understand? So this is alpha keto group, meaning that at the alpha carbon, there is a keto group there. This right here now is a keto group. So this what gives the name alpha ketoglutarate. At the alpha carbon, there's a ketone group there. So now we have to look at the next step of the reaction. The first step of the reaction, which is, do you know why this thing is not an amino acid? Because where is the amine group? There's no amine group. So you have to add an amine group. It's the amine group that makes this become the amino acid. So when you add an amine group to it, NH4, then the coenzyme that is required is NADH. And nicotinamide adenine dinucleotide plus a hydrogen atom, it will come out to form NAD. Yes. So what is formed now? What is formed now is glutamate. Glutamate is formed from alpha ketoglutarate. So what will happen is that this amino group will come and replace the ketone group. So now at the alpha carbon now there will now be an amino group. There will be an amino group. So you can see everything remains the same apart from here, which is here. So this here right now, this is the glutamate. This is the glutamate. So what do you think would be the name of, do you know what, so the name of the enzyme that catalyzes this step is glutamate dehydrogenase. Glutamate dehydrogenase. Glutamate dehydrogenase, any reaction that involves NAD, you always see it will be catalyzed by dehydrogenase. Dehydrogenase in the sense of there was a removal of the hydrogen group. There was a removal of the hydrogen group. But now if you look at, there was actually an addition of the hydrogen group. So you might be like, why are we calling it glutamate dehydrogenase? The reason is because this thing is actually a reversible reaction. So glutamate, when you are going from glutamate to alpha ketoglutarate, there will be a removal of the hydrogen group. So this glutamate, the enzyme is actually named for the reversal group when you are going back. So this enzyme, this reaction, you can call this reaction reductive amination. This one going from here to here is reductive amination. In the sense of there was addition of a hydrogen group. Reductive amination. There was an addition of a hydrogen group and there was an addition of an amine group. So this is why we call this reductive amination. But if we were to go here, it will be, if we were to go from glutamate to alpha ketoglutarate, we then call it oxidative deamination. The oxidative part of it is because of the removal of the hydrogen group. Removal of the hydrogen group, and then the deamination means that amino group was removed from the glutamate to form the alpha ketoglutarate. So now let's look at the next step of the reaction, formation of glutamine. This now, with this now, glutamate has been formed. So let's look at the next step, how you can form glutamine if you wish to form glutamine. So glutamine is formed by the addition of another amino group. Another amino group. When you add another amino group to glutamate, you form glutamine. So it's not really hard, right? So, but this one is ATP dependent. It is ATP dependent, meaning that you add a more, it is ATP, it requires energy form of ATP. But it now cleave it to ATP and then phosphate. Understand? ATP, adenosine triphosphate, 3 molecules of phosphate. ADP, adenosine diphosphate. The remaining molecule of phosphate, this is it as inorganic phosphate. Understand? So this part, this step of the reaction, so let me just show you where the amino group enters. Because the first amino group, it entered here, right? But this second amino group that's entered now, we actually enter here. It will actually enter at this carboxylic here. So let's look at it here. So it will be like this. Sorry. So this, okay. So this would have been the same thing, right? But the only difference is that, you know that the carboxylic, this, you can also write it like this. This here and this here is the same thing. You understand? So this one now, the amino group will come and displace this one. So the amino group will actually enter here. So this one now is the glutamine. This right here is glutamine. Yes. So what do you think would be the name of the enzyme that synthesizes glutamine? The name of the enzyme will be glutamine synthetase. So yeah, glutamine synthetase. As per glutamine is synthesized and it required ATP. If it didn't require ATP, it would have just been glutamine synthase. Yes. So with this now, this is the formation of glutamate and glutamine, non-essential amino acids. They were formed from alpha ketoglutarate, which is an intermediate of the citric acid cycle. So now let's look at formation of aspartate and asparagine. That looks very, very similar to this. So let me just write it down here. Formation of aspartate and asparagine. So now, okay, aspartate and asparagine is formed from another intermediate of citric acid cycle called oxaloacetate. So here's how it looks like. So this right here is oxaloacetate, a four carbon compound. You understand? So a four carbon compound. So this will go on. But you know the difference between the difference between these reactions, formation of glutamate, and sorry, formation of aspartate and asparagine. The difference between this one and this one is that the amino group is gotten from glutamate. See it, gotten from glutamate, and alpha ketoglutarate will leave. Alpha ketoglutarate will leave the reaction. So what happens is that glutamate will come in, donate amino group, and then leave as alpha ketoglutarate. Look at glutamate here. It will just come, donate this amino group, then it will go back to this. Yes, it will go back to this. Yeah. So, yeah, we go back to this. So now join this. It will now look like this. Okay, I didn't add something here. H2 also left here. This is plus H2O. Yeah. H2O also left here. That is correct. Okay, yeah. Okay. So glutamate comes in, alpha ketoglutarate leaves. So now drawing the structure of this one, it now looks like this. It now look like this. It now look like this. So this right here, this is this is aspartate. This is aspartate. So when there will be information, the next reaction to form asparagine is that another glutamine will come in, and glutamine will come in, and then glutamate will leave. But for this reaction, what do you think will be the name of the enzyme that catalyzes this step? What do you think will be the name of the enzyme that catalyzes this step? This is a transamination reaction. Transamination reaction, it says that there was a transfer of an amino group from glutamate to oxaloacetate to form aspartate. Since it's a transamination reaction, it's actually called, since it's a transamination reaction, it's actually called, okay, it's actually called aspartate. Aspartate aminotransferase, or you can actually call it aspartate. That's aspartate aminotransferase, transfer of an amino, or you can call it transaminase, AST for short. Transaminase. So for this one now, this one is formation of asparagine. So the same thing that happens here, we'll just add to. So this here is asparagine. Asparagine. So what do you think will be the name of the enzyme that catalyzes this step? Formation, synthesis of asparagine. And it requires as well, the same way that this one requires ATP, this same way that like that, ATP requires ATP to form ADP plus a phosphate group, inorganic phosphate. So what will catalyze the step will be it will be catalyzed by asparagine synthetase. Okay, so this as well is a transamination reaction, transfer of an amino group from glutamine to aspartate, and then glutamate is formed. Remember, the difference between glutamine and glutamate is the extra amino group there. So yes, this is the formation of four. We have now discussed the formation of 4 non-essential amino acids. So let's look into more of them, of the amino acids. Okay, so I want us to talk about the formation of. Let's talk about the formation of alanine from pyruvate. Pyruvate is the end product of glycolysis, right? So yes, let's talk about formation of, this one is a very, very simple one, whereby this is the structure of pyruvate. This right here is the structure of pyruvate. So this right here is a very simple one. Glutamate will come in and alpha ketoglutarate will come out, just like we did last time. a transamination reaction, transfer of an amino group from the glutamate to form alpha ketoglutarate. So it's kind of saying that alpha ketoglutarate is the carbon skeleton, of glutamate. Do you understand? So when you transfer amino group to here, the same kind of thing that happened in the last video. So what will now form is, what will form will be same thing, the ketone group. There will not be an amino group here. There will be an amino group here. So there will be an amino group here. And then, so that was all. That was all I changed. So this right here is what? This right here is pyruvate. And this is alanine. Alanine, an amino acid. You can see the amino group. You can see the carboxylic acid group. And then, yeah, so this is the R, the side chain. That's it. So this is catalyzed by alanine, the same way you know that or the other one. Alanine amino transaminase, transferase, or you can call it transaminase. So this is a simple one, right? Yeah, this is a simple one, right? So then let's now look at a slightly more complicated one, formation of serine from another intermediate of glycolysis. The intermediate of glycolysis we are looking at this time is 3-phosphoglycerate. But I want to teach you two ways of this way that we'll be using to explain the structures. It's actually called, let's just call it the displayed form of displaying structures. But there's a simpler way in which we call it the skeletal structures. Like, you know that this, for instance, you know that this right here, you know that this is a structure. You know that this is a structure. This is a simple, that's why they call it simpler way to represent structure. In this simpler way to represent structure called the skeletal form, the skeletal formula, the carbon and the hydrogen will not be shown, but it's implied. The only thing that can be shown in this way of representing formula is the functional group. So look at this now. Carbon bonded to a carbon, bonded to a carbon. This actually is carbon here 1, carbon here 2, carbon here 3, carbon here 4, and then carbon here 5. So there is actually a 5-carbon compound. So carbon to carbon to carbon to carbon to carbon. Understand? So like I told you, the hydrogen is not there, but it's implied. What I'm trying to say is that there's actually a hydrogen here, a hydrogen here, there's a hydrogen here, there's a hydrogen. I don't want to kind of, so like this hydrogen now, you understand? It's actually implied, but it won't be shown. Same thing as this carbon 2 now. This is carbon 1, right? This is carbon 2. There's a hydrogen here, and hydrogen here, but it won't be shown. You just have to know that carbon has to be bonded to 4 different atoms. So the carbon is bonded to 1, 2, 3, and 4. The same thing as the carbon is here, bonded to 1 carbon atom here, 1 carbon atom here. Then you just have to know that there's a hydrogen here and the hydrogen here. It's a simpler way of representing structures. The only thing that can be shown, is when there's a functional group in the. So I assume there's a functional group here. You have to represent it in the structure. You have to represent it in the structure. So this is carbon 1 right here. So carbon 2 here. This is carbon 1, carbon 2 here. So you have to put the OH here. Assuming there's a functional group here, you also have to show it. Like you won't show the hydrogen, these hydrogens, all these hydrogen, but you have to show the functional group. So this carbon 1, carbon 2, carbon 3, carbon 4. Carbon 1, carbon 2, carbon 3, carbon 4. You understand? So you have to put this functional group, COH, yes, the carboxylic acid functional group. So I hope you've understood this way of representing structure. I want to use it to explain for you the formation of serine. So you don't get confused in your textbooks when you see this way of representing structures. I'll still make a full video on these different ways of representing structures in biochemistry. So now, let's now look at the formation of serine. Serine is formed from 3-phosphoglycerate. 3-phosphoglycerate is an intermediate of glycolysis, right? So this is how 3-phosphoglycerate looks like. 3-phosphoglycerate, that's carbon, carbon, carbon. 3-phosphoglycerate means at the third carbon there is a phospho group. right? So it's more like this, hydrogen here, hydrogen here. So at this third carbon, now there's a phosphor group like this. Or I can try to draw it out, or I can just simply make it like this. You understand? This is how to just make it smaller. You understand? This is how to just make it smaller. So now, carbon, carbon. Okay, so but when you want to represent it in character structure, you have to make it like this: carbon 1 here, carbon 2, carbon 3. Do you understand what I just did now? Carbon 1. So okay, this is actually OH here. This is so this is what 3-phosphoglycerate looks like. 3-phosphoglycerate looks like an intermediate of glycolysis. You will see that in my video on glycolysis. So now, okay, so this carbon 1, carbon 2, and carbon 3. So they say that carbon 2, there is an OH group there. So of course you have to add it, the OH group. Then at carbon 1, the first carbon, there is this so here you can kind of, yeah. So this here is this is this. Then here, bonnet to oxygen, bonnet to phosphate. So it's like you can put like this, and then I can just write the phosphate group like this. Just now this represents this. I can just make it simpler. So now let's look at the next step of the reaction. The next step of the reaction is oxidation, removal of this hydrogen here. So let me write the name of this. This is 3-phosphoglycerates. So the next reaction is formation of phosphohydroxyl glycerates. So it's like this. There will be removal of the hydrogen group. NAD will come in. NADH goes out. Catalyzed by what? Okay, so let's look at the structure. So everything will be the same. Everything will be the same. But look now. Here now, there will now be only oxygen here. There was removal of a hydrogen group. Understand? So this now is okay. So this now is phosphohydroxyl gases. So let's now look at the next step of the reaction, whereby an amino group will come in. So this is phosphohydroxyl glycerate. So when an amino group now comes in, the amino group will come in. So look at what happens here. This when amino group come in, it will replace this oxygen here, the oxygen here, the keto group here, will replace it. NH4 comes in here. So look at it here. So there will now be an NH. Sorry, there will now be an NH2 here. Yes. Then you complete the structure. So this right here is called, this here is called phosphoserine. Phosphoserine. So the only thing that is now making it is not a serine because there's still the phosphor group here. So next step has to be the cleavage of the phosphor group to form the serine. So what do you think will be the name of the enzyme that catalyzes this step? The name of the enzyme that catalyzes this step will be called phosphoserine transaminase. Phosphoserine transaminase. So write that phosphoserine transaminase here. Phosphoserine transaminase, because there was a transfer of an amino group to phosphoserine to form phosphoserine. You understand? So now let's look at the final step of the reaction. the final step of the reaction, whereby there will be a cleavage. There will now be a cleavage of this. So what will now be formed will be, sorry, there will be a cleavage here rather. So what will now be formed is an amino group here. So this right here is serine. Yeah, this is serine. This right here is serine. So what do you think will catalyze this step now? This step will be catalyzed by serine phosphatase, because there was a cleavage of the phosphate group. The phosphate group left. There was hydrolysis here. H2O came in with the cleavage of this. H2O came in, and then phosphate, and inorganic phosphate left. So there was a cleavage of a phosphate group. So this is phosphoserine phosphatase because of the removal of the phosphate group. So this is now the serine that is formed. Yes, this is serine that is formed. So if I want to represent serine, you can attempt representing serine in this format. Can you give that an attempt? Okay, so if I want to represent it, this is carbon 1, carbon 2, and carbon 3. Carbon 1, carbon 2, and carbon 3. Then there is a for carbon 1. Then carbon 2 has an amino group. Right? Then the hydrogen is implied because carbon has to be bonded to 1, 2, 3. It has to be bonded to 4 different atoms. So there's a hydrogen atom here. And then for the fourth one, there's an OH group here. OH group. Then the other hydrogen atoms are implied. So this right here is actually serine. This is also serine. This is two different ways of representing it. You understand? So this was the formation of serine. Let's now look at a very short one, formation of glycine from serine. Very short one. Formation of glycine from serine. Okay. Okay, I want us to look at the final amino acids, the final synthesis of amino acids I want us to look at for the end for this video. So that's the formation of glycine from serine. Yes. So for the last, so remember, this is carbon 1 here. So this is carbon 1 here, carbon 2, carbon 3. So at carbon 1, that's the carboxylic group, right? So there's the carboxylic group at carbon 1. At carbon 2, there's the amino group. Remember, at the carbon 3, there is now an OH group. So this is serine. So this is not hard at all. Serine will go. So this is not hard at all. This is methylene. There will be a cleavage here. Understand? So tetrahydrofolate will come in. Tetrahydrofolate, you can write it as THFA. Anyhow, this is just tetrahydrofolate. Understand? It will come in and then break off with this one. Remember, this is carbon 3 here. There's actually a H here, a H here. So it will break off with this one and form methylene tetrahydrofolate. Understand? So when this goes, so this I'll just bring is just this part. That's the glycine. That's just this. That's the only thing that will remain here. So not difficult, right? So this one is the glycine. So what do you think will be the name of the enzyme that catalyzes the transfer of the hydroxy methyl from here to hydrofolate? The enzyme will be serine hydroxy, sorry. So the name of the enzyme will be serine hydroxy methyl transferase. Yes, because there was a transfer of hydroxy methyl from this is hydroxy methyl. If you want to look at it at structure, if you want to look at it displayed with everything displayed, you see that this is carbon 1, right? COO, yeah. Carbon 2 here with the amino group here, and then and hydrogen is not that is implied, but it's not shown in this skeletal structure. There is a hydrogen here, and then this OH here. There is a carbon that is the OH, and then H here. H here. So I'm saying that there was a cleavage at this point. There was a cutoff at this point. Cutoff at this point. So this here now with the hydrogen. This with the hydrogen. This now is glycine, and it's catalyzed by this enzyme here, serine hydroxymethyl. Because this is hydroxymethyl, right? Hydroxymethyl. So it was a transfer of hydroxymethyl to tetrahydrofolate to form methylene tetrahydrofolate. So this is all for synthesis of non-essential amino acids for this first part of the video. All right, thank you very much, guys. Don't forget to subscribe, like, and comment. Thank you.